The British had an interesting tradition. They loved naming their heavy, multi-engine aircraft after major cities in their overseas territories. This was meant to highlight the global power and grandeur of the British Empire. It was the empire on which the sun never set. That is how we got iconic aircraft like the Vickers Wellington, the Bristol Bombay, and the Blackburn Perth. The Canberra was the last aircraft in this symbolic lineup, but it came with an ironic twist of fate. By the time this brand new bomber took to the skies, the once mighty empire was already crumbling, and Canberra had become the fully established capital of an independent Australia. In mid-1944, the British Air Ministry began drafting requirements for their first ever jet bomber. They already had a massive head start for such an ambitious step. By that time, British engineers had racked up a good amount of practical experience. They had been designing and operating jet engines and the aircraft they powered. Prime examples included the Gloucester Meteor and the de Havilland Vampire. It is also highly likely the British leadership got an extra push from some alarming intelligence reports. These indicated that Nazi Germany already had its own jet bombers in service. One example was the Arado AR-234 Blitz. This name translates from German as lightning. However, since the jet age was just dawning, those initial requirements were more like rough guidelines than final specs. While designing the new aircraft, engineers constantly look back at the incredibly successful track record of the famous de Havilland Mosquito. The military brass made their expectations clear too. They wanted this new bomber to be a worthy jet-powered successor to that legendary wooden wonder. The new bomber was expected to boast some seriously impressive numbers. It needed a cruising speed of around 500 miles per hour. It required a range of over 1,500 nautical miles. The operational ceiling was set between 36,000 and 46,000 feet, and it had to carry a 6,000-pound bomb load. The massive task of turning this ambitious concept into reality fell to English Electric. They were based in Preston, Lancashire. At the time, the company was successfully manufacturing aircraft under license. This gave them the financial resources to take a risk and invest in their own in-house design. On top of that, in 1944, brilliant engineer William Teddy Petter signed on as their chief designer. He had come over from Westland Aircraft. There, he had already made a name for himself designing the Lysander Army Cooperation Aircraft and the twin-engine Whirlwind fighter. Taking on the new project, Petter carefully analyzed recent combat experience from World War II alongside the military requests. He went all in on the concept of a highly streamlined extreme altitude bomber with long range. The core idea was simple. Thanks to its high speed and operating altitude, the new aircraft could completely ditch heavy defensive armament and gun turrets. This bold approach had already proven highly effective on the Mosquito. The engineering team drew up a series of design studies. By May 1945, the final configuration was locked in, promising phenomenal performance. The concept was designated the A1. Right around this time, Rolls-Royce was developing its new AJ65 axial flow turbojet. This engine was projected to put out an incredible 6,600 pounds of thrust. Petter decided to power his aircraft with two of these new engines. He elegantly integrated them directly into the wings. The wing itself became the defining feature of the A1 project. Instead of the swept wing designs that were becoming so popular at the time, the engineers went with a classic, straight, but relatively broad low aspect ratio wing. It featured an exceptionally low wing loading of around 41 pounds per square foot. This engineering choice was brilliant in its simplicity. It allowed the aircraft to climb to its maximum cruising altitude, where it was virtually untouchable by enemy fighters. At the same time, it gave the bomber excellent handling and maneuverability, even at low speeds. The designers actually did consider a swept wing configuration. However, their calculations showed that it would make the aircraft about 35 miles per hour faster. That slight speed advantage did not justify increasing the bomber's overall weight by more than 4,400 pounds. After finalizing the technical details with the engine specialists at Rolls-Royce, the A1 project was officially presented to military officials. The Air Ministry was highly impressed with the well-thought-out design and the projected performance figures. As a result, in the fall of 1945, English Electric received an official government contract. This contract was to build the first 4 flying prototypes of this innovative new bomber. On January 7, 1946, preparations for full-scale production officially got underway. At the same time, the company's engineers were developing specialized high-altitude equipment. They used a heavily modified Meteor F-4 fighter to test it in actual flight conditions. Meanwhile, throughout 1946 and 1947, Rolls-Royce was hard at work. They were developing a new turbojet engine, which was dubbed the Avon. But chief designer William Petter decided to play it safe. He reworked the second prototype to accommodate a different set of Rolls-Royce engines, the Ninis. These had already proven themselves in production, even though they produced significantly less thrust than the newer Avon designs. Alongside the prototypes, the team also built a full-scale mock-up of the aircraft. This was absolutely essential for carefully configuring and testing all the internal onboard systems. Assembly of those first prototypes progressed slowly, dragging on for over 2 years. This was mainly because the engineering team kept running into entirely new technological challenges. They had to solve these problems from scratch. For example, right in the middle of the assembly process, they decided to swap out the initial Avon RA-1 engines. They replaced them with a much more powerful version, the Avon RA-2. Each of these new turbojets produced what was then an incredible 6,000 pounds of thrust. However, all this long and painstaking work on the prototypes came with a major payoff. The Air Ministry saw just how meticulously the aircraft's design was being refined. As a result, in March 1949, the military placed a massive order. This happened before the bomber had even taken to the sky for the first time. They requested 132 production aircraft right up front. These were spread across 3 different variants: a standard bomber, a reconnaissance platform, and a trainer. Finally, the highly anticipated moment arrived. On May 13, 1949, Chief Test Pilot Roland Beaumont took the controls. Flying out of Wharton Airfield, where the design bureau had relocated, he took the first prototype of the new bomber into the air for its maiden flight. It was an absolute success. On just his second flight, Beaumont pulled off a series of complex aerial maneuvers. This immediately proved that the aircraft responded flawlessly to the controls. Later that summer, this exact prototype became the star of the show. It demonstrated its outstanding flight characteristics at the famous Farnborough Air Show. Testing for the remaining 3 prototypes went just as smoothly. The last of these was specifically used to test mid-air refueling. This was a critical new capability. When it entered service with the Royal Air Force, this cutting-edge bomber was officially designated the Canberra B Mark I. But before the aircraft could enter full-scale production, the design had to be tweaked to meet some new requirements. During the Canberra's initial design phase, it was intended to have a crew of just 2, a pilot and a navigator. They were supposed to rely on the latest high-precision bomb-aiming avionics. But reality got in the way. By the time flight testing began, this advanced equipment was still in development and nowhere near ready. As a result, the Air Ministry handed down a strict new requirement. Production aircraft would need a station for a 3rd crew member, a bombardier, and traditional optical sights had to replace the complex electronics. Chief designer Petter had to scramble to redesign the nose section. He added extra glazing for better visibility. At the same time, engineers designed new mounts for more powerful turbojet engines, the Rolls-Royce Avon RA-3. Each of these put out an impressive 6,500 pounds of thrust. They also added teardrop-shaped external fuel tanks to the wingtips to extend the aircraft's range. It was in this updated configuration that the aircraft was officially adopted. It was then sent to the assembly line under the designation B Mark II. The first production Canberra made its maiden flight on April 21, 1950. At the controls was once again their chief test pilot, Roland Beaumont. Meanwhile, the Korean War was rapidly escalating. Recognizing the threat, the British government decided to accelerate the rearmament of its bomber force. To get Canberras rolling out faster, production was expanded beyond the main English electric plant in Preston. It grew to include facilities from other aviation giants like Avro, Handley Page, and Short Brothers. Alongside the main bomber variant, production of specialized versions also began, though in much smaller numbers. These included a high-altitude photo reconnaissance aircraft and a pilot trainer. For the trainer version, the forward cockpit was heavily modified. It featured side-by-side seating for the instructor and student, along with dual flight controls. Overall, RAF leadership and the Air Ministry had massive plans. Factoring in future export orders, they expected to build around 1,000 Canberras. The aircraft was slated to become the standard tactical bomber for the Royal Air Force. In December 1950, the first production Canberras began arriving at training squadrons. An intensive training program for new crews kicked off immediately. Interestingly, the conversion process turned out to be surprisingly short. To fully qualify a combat pilot, all it took was 20 flight hours in Gloucester Meteor jets. It also required just 3 hours of stick time in the Canberra trainer. This was a testament to just how forgiving and reliable the new jet bomber really was. Thanks to this easy learning curve, by January 1951, Bomber Command's operational squadrons began a massive transition. They started moving to the new Mark IIs. The legendary 101st and 617th Squadrons were the first to receive the advanced aircraft. Even while producing aircraft in massive numbers, English Electric continued their research and development. In July 1952, an entirely new prototype was rolled out for testing, the B Mark V. Based on the earlier B Mark II, this was an experimental aircraft designed for target marking. In fact, this airplane marked the beginning of the second generation of Canberra bombers. Why? Because it was fitted with the much more powerful Avon RA-7 jet engines. These produced around 7,500 pounds of thrust each. Plus, the aircraft was equipped with new fuel tanks integrated directly into the wings. As a result, the bomber's performance improved dramatically. Externally, the easiest way to spot this variant was by the flat, optical glass panel on the underside of the nose. However, despite all the innovations, it never actually entered full-scale production. Around the same time, engineers were actively experimenting with other engines. They tested the Bristol Olympus and Armstrong Siddeley Sapphire power plants. They even built dedicated test beds for the task. But ultimately, they chose to stick with the reliable Avon engines. Drawing on everything they learned from the B Mark V, the designers developed a new and highly promising variant. This was the B Mark VI. Its first flight took place in June 1954. The fuselage on this aircraft was stretched by about a foot. Later on, some of these aircraft were converted into night intruders. To do this, they fitted a special gun pod under the fuselage. This pod housed 4 20mm cannons. The success of the Mark VI also paved the way for a high-altitude photo reconnaissance variant. This was the PR Mark VII. Just like earlier models, they stripped out all the bombing equipment. They replaced it with high-powered cameras for high-altitude photography. Fast forward to the 1953 to 1954 timeframe. Chief designer William Petter and his team of engineers were taking a hard look at lessons learned from the air war in Korea. The takeaway was obvious. The Canberra's mission profile as a tactical bomber needed to be expanded, and fast. The aircraft was expected to do more than just drop bombs from level flight. It had to effectively destroy enemy supply lines. This meant it needed heavy forward-firing armament. On top of that, the military wanted a bomber that could be quickly converted for photo reconnaissance in the field with minimal effort. And most importantly, it had to be capable of carrying tactical nuclear weapons. To meet all these stringent requirements, Petter came up with a unique concept for a versatile, high-altitude intruder bomber. This concept became the foundation for the new BI Mark VIII prototype. Keeping the airframe and engines from the previous Mark VI, the new aircraft featured a completely redesigned nose. The crew was reduced to a 2-man team. To give the pilot a perfect view of the battlefield, they installed a large bubble canopy. This canopy was uniquely offset to the left of the aircraft's center line. The navigator, meanwhile, had 2 stations. The first was a jump seat located right behind the pilot for takeoff. The second was a primary station in the fully pressurized nose section, housing the optical bomb sight for bombing runs. For ground attack sorties, Boulton Paul created a highly compact gun pod. It could be quickly mounted or removed. It housed 4 20mm British Hispano cannons. However, heavier 30mm guns could easily be installed if required. This gun pack was tucked away in the rear bomb bay. Under the wings, they added 2 pylons. These could carry 1,000-pound bombs or unguided rocket pods. If reconnaissance was needed, crews could swap the gun pod for reconnaissance cameras in the rear bay. They could also load 16 photoflash flares into the forward bay for night missions. In its nuclear configuration, the bomber could carry a single tactical nuclear bomb. It utilized a complex lab's electronic system for precise delivery. On July 23, 1954, this formidable BI Mark 8 prototype took to the skies for the first time. It departed from the airfield in Preston. The flight trials wrapped up quickly and were highly successful. As a result, the Air Force immediately gave the green light for full-scale production. These aircraft were assembled simultaneously at 2 factories. These were English Electric in Preston and Short Brothers in Belfast. Altogether, 73 of these versatile Canberras were built for the Royal Air Force. By January 1956, the first production bombers started arriving at bases in West Germany. Around the same time, the factories were also rolling out the specialized PR Mark 9 photo reconnaissance variants. These things were absolute giants. Their fuselages were stretched to nearly 68 feet. They were fitted with the latest Avon RA-27 engines. Each engine cranked out over 10,000 pounds of thrust. The wingspan was also increased by 4 feet. This provided better handling in the thin air at extreme altitudes. The Belfast plant alone built 22 of these high-altitude spy planes. The Mark 8 ended up being the last bomber variant of the legendary Canberra. It was also arguably the most successful. But by the mid-1950s, the landscape of air combat had completely changed. Supersonic fighters were entering the scene. They packed powerful airborne radars and the latest air-to-air missiles. From then on, sending Canberras out on tactical bombing missions in major theaters of operation only made sense under one condition. Allied forces had to have total air superiority and provide solid fighter cover. It made a lot more sense to use these aircraft in local conflicts. In these areas, the risk of running into a modern peer adversary was pretty low. Because of this, the Mark 8 only saw a limited production run. Plans to develop any future bomber variants of the aircraft were scrapped altogether. But the story of the aircraft did not end there. There was still a great opportunity to use Canberras as trainers and in various utility roles. The engineers at English Electric and the top brass at the RAF jumped at the chance. For example, they started converting older, obsolete models into brand new crew trainers. And as part of several experimental programs, those same older airframes were converted into target drones. This was done to train air defense crews. The most successful conversions were 2 special variants. These were produced in small numbers during the 1960s. The first one served as a true flying classroom to train airborne radar operators. These operators would go on to crew all-weather interceptors. To pull this off, they packed the nose of the Canberra with a whole array of antennas. These came from different types of radar systems. The other version was used to train electronic intelligence and electronic warfare specialists. For this purpose, the aircraft was loaded with the latest top-secret gear. On top of that, they converted a few aircraft to serve purely as target tugs for gunnery practice. Eventually, in the early 1960s, a number of the production Mark 6 bombers received a major upgrade. They were fitted with new equipment and special underwing hardpoints. Now the bombers could carry 1,000-pound bombs. They could also carry pods loaded with unguided rockets. The Canberra's success did not go unnoticed overseas. It was not long before the first international contracts rolled in to export these versatile aircraft. Australia became the first foreign customer. The Royal Australian Air Force began negotiations back in early 1949. This was even before the very first prototype had finished its flight test. Their goal was to set up licensed production of the aircraft domestically. In 1951, the Australians bought 2 early production bombers. This allowed them to immediately begin pilot training. That same year, a government-owned Australian plant began rolling out a batch of 48 new Canberras. The most significant difference was the addition of integral fuel tanks built directly into the wings. This gave them a substantially larger fuel capacity. Later on, 7 of those Australian aircraft were converted into trainers. The United States also took a strong interest in the Canberra. At the time, the United States military was in desperate need of a large fleet of reliable tactical bombers. In 1950, senior United States Air Force officers got a close look at the British prototypes. Then, on February 21, 1951, one of the production bombers proved its capabilities. It made an unprecedented non-stop transatlantic flight from Northern Ireland to Newfoundland, Canada. From there, it flew straight to Andrews Air Force Base. After putting the aircraft through rigorous testing, the Air Force was highly impressed. They decided to set up licensed production at the Martin plant. American engineers heavily reworked the original design to meet United States standards and requirements. This extensive redesign essentially created an entirely new bomber. It was designated the B-57, also known as the Martin Model 272. Since this American counterpart ended up being structurally very different from the classic Canberra, it is a completely different story. It deserves its own separate deep dive. In 1952, 4 Canberras went on a major demonstration tour. They flew across 14 countries in Latin America. This tour acted as a catalyst. Soon after, orders from countries across the region started pouring in. For example, in 1953, Venezuela bought 6 aircraft. A few years later, they expanded their fleet with 8 more of the heavier strike variants. Ecuador and Peru did not sit on the sidelines either. Ecuador bought 6 aircraft. Meanwhile, Peru ended up operating nearly 40 bombers across several different variants. Chile ordered specialized photo reconnaissance aircraft. Argentina picked up both combat and trainer versions. Special dual-control variants were also built for the air forces of New Zealand and South Africa. But the largest foreign customer by far was India. In 1957 alone, the Indian Air Force took delivery of over 80 aircraft. This included a mix of bombers and reconnaissance planes. These aircraft were specially built by Boulton Paul to a tropicalized specification. This allowed them to operate effectively in the hot climate. Later on, India purchased another 15 airframes. Throughout the 60s, these reliable aircraft were procured by several other nations as well. This included Southern Rhodesia, Qatar, and Ethiopia. When it comes to the European market, the Canberra's export success was quite a bit more modest. France bought a few airframes strictly to use as flying test beds. They were used for their own new aircraft engines and guided missiles. The Swedes limited themselves to just a couple of trainers. And in 1960, Britain transferred 4 of its bombers to the West German Luftwaffe. The Germans heavily modified them and used them for detailed aerial mapping. Overall, by 1962, a total of 949 Canberras had been built across a wide range of variants. The vast majority of them, 901 aircraft to be exact, were assembled at the British facilities of major aerospace companies. These included English Electric, Short Brothers, Avro, Handley Page, and Boulton Paul. Meanwhile, nearly 50 more were built under license down in Australia. The Canberra saw its first real combat during the 1956 Suez Crisis. British command was gearing up for Operation Musketeer. This was the military campaign to occupy the Suez Canal zone. They deployed a massive 17 bomber squadrons and 1 reconnaissance squadron to bases in Malta and Cyprus. The Canberras served as the main strike force there. On the last day of October, they flew their first combat sorties. They hit Egyptian military air bases hard. However, it did not come without losses. On November 6th, the conflict claimed its first and only Canberra. An unarmed photo recon aircraft was intercepted and shot down by Syrian MiG fighters. In December 1961, India answered the United Nations call. They deployed 8 of its bombers to the province of Katanga in what was then Zaire. Peacekeeping forces there were locked in heavy fighting with local separatists. Indian crews flew precision strikes against rebel airfields and supply lines. This unique combat experience in the African jungles really paid off for the Indian Air Force in 1965, during the massive Indo-Pakistani War. At the time, Canberras were actually the only fully combat-ready bombers in the Indian inventory. They were pushed to their absolute limits. They methodically destroyed enemy air bases and key rear echelon targets. These same bombers saw heavy use in subsequent wars with Pakistan throughout the 70s. But during the Falklands War in 1982, the aircraft found itself on the other side of the fight. The Argentine Air Force used 8 Canberras to bomb British ground positions and ships. During the day, they pressed their attacks under fighter cover from daggers. These fighters were an Israeli derivative of the famous French Mirage 3. At night, they operated entirely on their own. They dropped bombs from medium altitudes. Amazingly, not a single one of these bombers was shot down. This was true even with officially confirmed hits to their airframes from both surface-to-air and air-to-air missiles. Even decades after they were first built, Canberras soldiered on in active service. They continued to fly frontline missions for air forces in Latin America, India, and South Africa. As for Great Britain, the Royal Air Force actually pulled these bombers from the front lines way back in the late 60s. However, they found a new and incredibly important role for the aircraft. They equipped the Royal Air Force 360 Squadron with heavily modified trainers. These planes were packed with state-of-the-art electronic systems. They were used to train elite electronic warfare and reconnaissance specialists for both the Navy and the Air Force. The British originally planned to retire the Canberra for good in 1995. But it soon became obvious that these Cold War veterans were going to fly right into the 21st century. Aviation enthusiasts pointed out a remarkable fact. The Grand Old Lady, as the Canberra was affectionately known back in the United Kingdom, had every chance of celebrating an incredible half-century of continuous military service in 2001. The Canberra bomber was an all-metal aircraft. It featured a mid-wing design joined to a sleek, circular cross-section fuselage. This fuselage was internally divided into three main sections. A conventional single vertical stabilizer stood at the tail. The aircraft sat on rugged tricycle landing gear. The cockpit was located entirely within the nose section. It was securely sealed off from the rest of the aircraft by a pressurized bulkhead. To give the pilots excellent visibility, the nose and canopy were fitted with heavy-duty acrylic. Crew survivability was a top priority. For emergency egress, the pilots were equipped with reliable Martin Baker ejection seats. The navigator, however, had to bail out through a dedicated escape hatch in the nose section. Just aft of that pressurized cabin, engineers housed the brain and nervous system of the aircraft. This included all the vital avionics, along with the pneumatic and hydraulic system components. The real core of the Canberra's combat capability was tucked away in the center fuselage. That is where you would find two massive bomb bays. They featured doors that rolled open smoothly thanks to a heavy-duty hydraulic system. The wing was incredibly sturdy, built as a single continuous structure. Its main spar ran straight through the entire fuselage. The wing platform was unique too. From the wing root out to the engine nacelles, the wings were completely straight. Outboard of the engines, they tapered smoothly toward the tips. The leading edge had a 4-degree sweep. The trailing edge had a 14-degree sweep. To keep the aircraft maneuverable and responsive, it was fitted with balanced ailerons and hydraulically operated flaps. Additionally, dedicated speed brakes were mounted on both the upper and lower wing surfaces. The tail section had some unique design features of its own. The horizontal stabilizer was completely all metal. However, the vertical stabilizer used a mixed construction. Its forward section was built from wood and covered in aircraft fabric. The hydraulically operated landing gear retracted cleanly into the airframe. The nose gear folded rearward right into the fuselage. The main gear retracted inward toward the center of the aircraft. The wheels were equipped with reliable brakes and low-pressure Dunlop tires. This ensured a smooth and safe landing.